Okay, on the back, we're gonna use factoring to solve. And it looks like every one of these is a definite integral, so we should have no plus 2 pi ends. There should be a specific amount of answers here. Okay, let's start with number 7. And before we factor, maybe let's go over what we do. So x squared plus 10x plus 16. Let's say we have this. Okay, how would I find the solution? We would factor, and then we would split each one up and set them equal to 0 and solve, right? Okay, so we've got to do, this is like a refresh your mind. We've got to do the same thing here. So we're gonna factor, split up the terms, set them each equal to 0 and solve. Okay, and the biggest important thing about this is that we have to equal 0 first to be able to do that. Okay, so if we look at 7, that one equals 0. So we should be able to just factor it right now. Okay, and this is a difference of squares, which says a squared minus b squared will factor to a plus b, a minus b. Or in other words, you square root the first one, square root the last one gets a plus, one gets a minus. So let's do that now. Okay, we'll square root the first, that's 2 cosine x. Square root the last one gets a plus and one will get a minus. Equals 0. Let me zoom out. Okay, one gets a plus, one gets a minus. So then we're gonna split them up. Set them equal to 0, maybe draw a line down your paper. Okay, and then you solve for cosine x just like we did on the front. So now this is what we were doing on the front. 2 cosine x equals -1. Cosine x, -1/2. Okay, then the other one, 2 cosine x equals 1. Cosine x equals 1/2. Okay, so I need to list everything on my interval from 0 to 2 pi. That will have a cosine of -1/2 and 1/2. All of them need to be included. So cosine x is -1/2 at 2 pi over 3 and 4 pi over 3. Okay, and then cosine x is +1/2 at pi over 3, 5 pi over 3. Okay, so if we're listing them, oh, looks like we can put them in order. Pi over 3, 2 pi over 3, 4 pi over 3, 5 pi over 3. You can just list them. They can be in any order. Doesn't matter. But those are the 4 answers from 0 to 2 pi. Okay, next one, 8. We're looking at from pi to 2 pi, but maybe let's just focus on factoring it first and then we'll decide our solution. Okay, so it has to equal 0. I'm going to subtract cotan x sine squared x from both sides. So this would be cotan x minus cotan x sine squared x equals 0. And we're using factoring here, so you should definitely be seeing that cotangent is in both these groups. That's what we're going to factor out. Okay, so now I have 2 factors I can split up and set equal to 0. Now this one you could also make cosine squared x equals 0 and you should get the same answer, but I'm just going to split it from here. So cotan x equals 0 and 1 minus sine squared x equals 0. Obviously this one's solved. It will be the same place that tan equals 0 because the reciprocal is, oh, excuse me, sorry, cotan x is 0 over 1, so the tan x will be 1 over 0, which is undefined. So you want to list where tan would be undefined. Okay, now let's look at the other side. If I add sine squared x and square root both sides, remember we want the plus minus 1 sine x. Okay, so I'm going to list out all the places that this occurs, and then I'll pick only the ones between pi and 2 pi. Okay, so where is tan x undefined? At pi over 2 and 3 pi over 2. Okay, then where is sine plus minus 1? So all the ones that are 1 and negative 1, the same. Okay, so what's our solution that fits in that interval? Only 3 pi over 2. Okay, pi over 2 isn't in the interval, so we're gonna cross it out. Okay, so even if you let this be cosine x, should have been the same thing, because you're answering where would the cosine be 0? Be the same places. Okay, cool. So next, number 9, we have 3 tan squared u minus square root of 3 tan u. It all equals 0, so let's factor out the common factor, which should be tangent u, times 3 tan u minus square root 3. Okay, just distribute and check yourself. You should get what you started with. Yeah. Okay, now those are 2 different factors we could split up and set equal to 0 and solve. So where's tan u 0? And where's 3 tan u minus square root of 3, 0? This one we're gonna have to solve more, obviously, so I'll add square root of 3 tan u is square root of 3 over 3, whereas tan u square root of 3 over 3. Okay, so use your unit circle. Remember, you can't just inverse tan on the calculator, because that's not going to give you all the possibilities. So where's the tangent 0? That would happen at 0 and pi. And then where is tan u square root of 3 over 3? That would be at the pi's over 6 and positives. So pi over 6. 7 pi over 6. Okay, so those are 4 possibilities, but we need to only list the ones between pi and 3 pi over 2. Okay, also notice I covered it up, but these have brackets, so we can actually include their values. So it will be pi, and what else would be between 3 pi over 2? 7 pi over 6. That's what u will equal. Okay, the other ones are outside of the interval. All right, couple more. 10. We can, well, it doesn't equal 0 yet, so we've got to subtract square root of 2 sine x, which is 1 square root of 2 sine x is. Okay, so now I'll be at sine x, secant x, plus square root of 2 sine x equals 0. And then we can factor out as sine x. Okay. Okay, so that's the greatest common factor. Now we can split up. Sine x equals 0. And secant x plus square root of 2 is 0. Sine x equals 0 at 0 and pi. Okay, and then we'll look at the next one. So we have secant x equals negative root 2. So to do cosine x, it'd be negative reciprocal, and we got to rationalize though. So this is negative root 2 over 2. Okay, so where's the cosine x negative root 2 over 2? 5 pi over 4. And the negative 3 pi over 4. Okay, so then let's choose the ones between 0 and pi. And that should just be, that just gets rid of 5 pi over 4. So we're at 0, pi, 3 pi over 4. So that's all of my values for x. Or if you want to, you don't have to list all the possibilities and then think about it. Like you could just say, okay, I'm gonna not even write that one down because it's not even in the interval. So you can skip that step if you want. Okay, next, so 11, cosecant theta. We wanna have everything equals 0 first, so we'll do cosecant squared theta plus cosecant theta minus 2 equals 0. So I subtracted 7 and then I added cosecant theta on both sides. Okay, so that ends up being, if you go to the left, if you had an x squared plus x plus 2, oops, x squared plus x minus 2, how would you factor that? Well, x, 2, 1, and we want a positive x. So that would be a positive 2 minus 1. Okay, so you're gonna factor this exactly the same way, but instead of x, it's a cosecant. Okay? So this will be cosecant CSC theta plus 2 times CSC theta minus 1. And then we gotta split them up now. So I have cosecant theta equals negative 2, cosecant theta equals 1, which is 1 over sine. So this would be the same thing as where is sine theta negative 1/2, and where is sine theta 1. Okay. So if you just look at the interval from 3 pi over 2 to 2 pi, we should only have one thing there. Hold on, 3 pi over 2 to 2 pi. So if I'm just looking at that as quadrant 4 only. So if you don't want to list all your possibilities out, you can just think about that. And the sine is at 11 pi over 6. And then where is sine theta 1 in that interval? Nowhere. Okay, so 11 pi over 6, that's it. All right, so you can also do that, like hone in on your quadrant and just only look at these values. Okay, all right, 12. Let's do the 12 the same way we did 11 by looking at the quadrant. Never mind. It's from 0 to 2 pi, so never mind. Okay, maybe next one. 12. So this is just like, okay, just like 2x squared plus 3x minus 2. Okay, and if you forgot how to factor that, you're gonna move the 2 to the back, x squared plus 3x minus 4, factor like normal. That'd be x plus 4, x minus 1, and then divide the 2. So it'd be x plus 2, 2x minus 1. So I definitely factor these by letting your sine, cosine, whatever it is, be x first, and then you'll just substitute back in the sine. Okay, so that would give me sine alpha plus 2. 2 sine alpha minus 1. Okay, so I'm going to split them up and solve. This would be where sine alpha -2 on 0 to 2 pi, and where is sine 2 sine alpha equals 1 sine alpha 1/2. Okay, so from 0 to 2 pi, where will you get sine alpha is -2? Nowhere. And sine alpha is 1/2. Positive 1/2 will be at pi over 6. 5 pi over 6. Okay. How about I'll just leave 13 and 14 as u tries. You should be getting pi, 4 pi over 3, 5 pi over 3, 2 pi for 13. And for 14, you should be getting pi 2 pi over 3 and 3 pi over 4, just on that interval. So you try those, and if you need help, you can ask during class. Oh, I don't know that you're gonna know how to do 14. Okay, 14's factoring by grouping. If you think you got it, you can stop. Okay, but if I let the tan squareds, or the tans be x, I factor by group here. So it'd be x squared, x plus 1, minus 3. So this would be x squared minus 3, x plus 1. So you'd have tan squared minus 3 and tan squared y, sorry, tan y plus 1. Okay, so now see if you can get these answers.